Hello everyone, I'm Harun. I work at ProSafety. Today I'm going to talk about a relatively new, young programming language, Rust. I am going to go through some code examples and I'm going to base my presentation on the idea behind this new feature that Rust introduces to us. So we can start. I don't know if we can make all of this because of that time, but I'll try my best. First, Rust. It is a young programming language. The first release was in 2015. And in the last 7 years, it has been the most popular programming language on Stack Overflow. It is a multi-paradigm language, which means that we can program in a imperative and functional way, but when it comes to object-oriented, it is not an object-oriented programming language because it doesn't fit all the requirements, because we cannot have inheritance in this language. It is famous for its memory safety and security. Rust introduces a borrow checker into its Rust C compiler, which is essential for the good memory and management. The installation of Rust is done very easily using Rust app tools, which can be downloaded online. The toolchain consists of a compiler called Rust C and a build tool and package manager called Cargo. In Rust, we have crates. Basically, those are library files. We can have either a binary or a library crate. A library crate is basically a C header file. We have all the functionalities that we want listed there. And the binary crate is basically a source file, and it gets compiled to an executable. Each of these crates has a cargo.toml file. Basically, that is a make file for Rust, but unlike make files, we don't have to put any code in it. All the code gets added automatically as we add files using the terminal, so we don't have to open this file anytime and at our work, and it will work perfectly, which is one of the benefits of Cargo, of Rust. That's it, and now I'm going to go through some functionalities that allow Rust the memory management. First of the functionalities is the ownership. It is a new term in Rust. I don't know any other programming language that uses this. It is basically the way how Rust manages memory. It is very similar to the move semantics in C++, but it is better. It consists of 3 rules. Each value has one owner, and there can only be one owner at a time. And when the owner goes out of scope, the value gets dropped. And that is connected to the array philosophy from C++. We have a constructor and a destructor called, basically a drop function that gets called when the variable goes out of scope. So now I have an example in C++ where I use the move semantics. First I have you can see the pointer. I have a string 1, and then I assign the value hello to it, and then I use the move so that I move this value hello to string 2. And what is this program going to print? Well, it's obvious it is going to print hello, but there is no problem. But imagine if we had, I don't know, 200 lines of code below this, and somebody is trying to use this string 1, which has no value. That could be a problem, and the compiler does not give us any messages regarding this. In Rust, well, first to note is that every non-primitive type, like int, unsigned integer, char, and others, when we do an assignment, we basically do a move. Or as in Rust, we would say we transfer the ownership of this value to this variable here. So here we transfer the ownership of the value hello to string 2. This is a move, so string 1 has nothing. And when we try to compile this program, we are going to get an error which says that string 1, basically it's invalid to use it anymore. And for me, I think this is a much better way to handle the move semantics than C++ is doing this. So you can note that every time we do assignment, we basically do a move. So how can we access a memory without taking the ownership or without doing the move? There comes the, when can we use this? Well, basically accessing freed memory or deallocated memory. On the right side, we have a C program. Well, everybody knows that the first time it is going to print 5, and when we try to access it, the memory, when it's freed, we are going to get some garbage. And in Rust, this program won't get compiled. I should explain a little bit. In Rust, we cannot operate on raw pointers because it's unsafe and shouldn't be used. So we must use this smart pointer. And when we call this function drop, this function takes the ownership of the value 5, and it gets deallocated. And then when we again try to access this value, we cannot do this because it is dropped, it is freed, and this program doesn't get compiled. On this side, it gets compiled. Some of you may say that if we use C++ unique pointers or shared pointers, this wouldn't be the case, but exactly the same output we would get if we use unique pointers, and the compiler wouldn't give any error messages. So borrowing, this is a way to access memory without taking the ownership. Basically, these are C++ references. It is important to know that Rust has two types of variables, mutable and immutable. What is this? Well, mutable means that we can change the value of a variable, and immutable means that we cannot do that. Borrowing consists again of 3 rules. Immutable borrows, we can have as many as we want. Mutable borrows, we can only have one mutable borrow, and we cannot have a mutable and an immutable borrow at the same time. So here I have a C++ example of a code. So I don't know if anyone would try to answer this question, will this program print hello? Probably not. So this program won't print hello. We get an assertion error at this line.
That's the error song.
So why is this? Well, I didn't get it the first time either. So when we declare the iterator, the vector basically it has a pointer behind it, and the iterator it also is a pointer, and they are pointing to the same number 1 until this first assertion. And then when we do the pushback, what is basically happening in behind, we are reallocating the memory. So the operating system tries to find a new slot for where we have place for 4 integer numbers instead of 3. But the iterator stays on the same point. It is still pointing to 1. And then when we try to access it, it is invalid, and it is not 2. So I hope I explained why do we get this. Basically, what on the second line is happening is a borrow. We have 2 variables, the vector and the iterator, that are pointing to the same point. That is, we can say that it's a borrowing. So this is the same thing done in Rust, but this program won't get compiled because of the reasons that I said earlier. So this is very, very good. I mean, we often do this, but we don't have in mind that this can happen. As I said, I didn't get this error at first either. And now there's something called lifetimes. Well, I'm going to explain this on an example. There is a C++ code. I'm using pointers. Well, I think that everybody can see that here I have a dangling pointer, which is not good. And when I compile this program, I will get no errors. and then I try to access it, and the behavior is undefined. Sometimes I get 5, sometimes I get some garbage. So we can say that this is not good. But in Rust, this will not get compiled. I'm using here references because I can't use raw pointers in Rust. I do the same thing. I'm making a dangling reference this time, but I get an error. I mean, the error is pretty clear. X does not live long enough. So I think that all of you can see that the variable x has a smaller scope than R, and then when we try to print it, we cannot access this memory because it's out of scope. So this everything Rust does in behind for us. We don't have to worry about this lifetimes, worry about dangling pointers and references. So when can we use this actually? In Rust we have something called generic lifetime annotations. So here I have done an example. I have a function called getBigger. Basically it has 2 parameters, references to integer numbers, and it returns the bigger value. So what could be a potential problem here? Let's say that the value epsilon is bigger than x, and that this print statement is not here. It is outside of this scope. And then when we will try to run it, we will still be making a dangling reference, but we wouldn't notice it. So in Rust, this program will get compiled, and if we try to actually print this here, we will get an error that the variable epsilon does not live long enough. So basically what I'm trying to say here is that a variable can have a different value and a different lifetime. In this example, the variable z will have the value of 7, but the lifetime of the value that has a smaller scope, which is epsilon. And this can also be used when we make some objects structs. We can have attributes that reference to another types, and we won't have to worry about making any dangling references, because in behind the compiler will give us a message if we do that. Now we have a small coding exercise, which is called find the largest number in an array. Well, probably all of you would do this code this way, but this code has a small problem. Well, what if the array is empty? What would we do? Well, probably most of you would throw an exception here, but exceptions are for something that is unusual. And an empty array is very common, and an exception would be something overkill to do, I think. We don't need it. In fact, the Rust does not have exceptions. It has something else called options enum. First, I would like to know that in Rust, enums can hold data. So every variant of an enum can hold different data, structs, tuples, integers, whatever you want. The option enum simply represents the presence or absence of a variable. So in this case, when the array is empty, we can simply return none, which means that the array is empty, and then we can handle this. We can handle all of this using this match statement, which is basically a switch case. Yes, and if the array is not empty, we can simply return the sum variant and the value of the largest number. So why does Rust have the option enum? Rust does not have a null pointer. So if we want to say that something is not there, we just put none. I don't know if you heard about the CrowdStrike event. Some of the Rust people say that this functionality could prevent that that event because somewhere in that code somebody was trying to access some null pointer, but in Rust we don't have null pointers, we have the none object, and we must handle it by hand. Some of the Rust people say that that could solve this problem, but the other guys don't agree, so I don't know. So traits, basically interfaces in Java. So they represent a set of functionalities that a type must implement in order to suit a trait. Here I have a simple example. I declare a 2D object trait with one method. I have an struct called circle with one attribute, and then I implement the trait for this object. And then I just made a new constructor, and I can use it. This is very good when we are dealing with a bigger project, when we want to have some functionalities, common functionalities defined. Pretty useful. So type safety. There are lots of documents that say that C and C++ are not type-safe programming languages. So why is this? Well, I have pointed is some. In C and C++ we have no void pointers. We have a lot of implicit conversions that is happening behind. In Rust we have none of these things. We cannot actually, if we have a function that has an attribute that is unsigned 8 integer, and we try to pass an unsigned 16, that the code will not get compiled. In Rust we also have built-in type for numerical values, and all of those types have a defined overflow and underflow behavior. So if we have an unsigned 8 variable a, which is 0, then when we try to subtract 1, the program will throw an exception. I mean, the program will panic. Basically, it would throw an exception that we have an overflow somewhere in the program, and this is pretty useful. Last week I had the same error. I was trying to assign an unsigned number to a signed number, and I didn't. I'm using C, and I didn't get this error. If I would use Rust, I would fix the error much quicker. So, embedded Rust. I will go when compiling for other platforms. It is very easy to add a new target in Rust. You can use Rust app tools, add a new target, whatever you want. And when you build the program, you just add the name of the target that you want to build it. I have done a comparison between a Blinky program that was written in C and a Blinky program written in Rust. And the memory consumption was pretty much the same. And also, I have done a speed comparison between a C program and a Rust program. And I've got the example was done on the example of a mathematical division. I've done simply a loop. I've done many of divisions, and the speed was, well, pretty much the same. The C side is something faster, but it is nothing that is, I don't know, significant. Testing. I would love to skip this part. I have prepared a demo where I use the Cargo tarpaulin tool, which is a coverage tool that Cargo provides to us. If you want, we can go to the example later. Well, this is some things that we can note. As I already said, in C and C++ we have make files, and in Rust we have the Cargo build tool. The problem with make files is that we actually need to code them. And when we use Cargo and the built-in, which is a built-in build system, we don't have to write any code. We can have a large project, hundreds of files, and everything will get linked behind for us. We don't have to write any code. The other disadvantage for C and C++ is a lot of compilers. When we use Rust, we don't only have one compiler, which is qualified for ISO 26262 certificate, which means that we can use it for critical automotive applications. And so I have some interesting topics. This is Tractor, maybe you have heard. This is a DARPA program. Basically, they want to make a large language model which will be able to transfer a project that is written in C to Rust. And also on this side, you have a pretty good video that talks about the same things that I've done, but longer. CrowdStrike already said that some people in Rust think that the options enum, only the options enum can prevent this thing from happening. And also I have a document here that from the American cybersecurity agencies, which list a number of safe programming languages, but C and C++ are not on that list, and Rust is. And that's it.
So, do we have any questions? Yes, please.
Okay, so, my question is, first, thanks for a great presentation, Harun. And my question is, how do we actually make Rust unsafe?
You have a keyword, you unsafe, and you enclose the code that you want to be unsafe, and then you can use raw pointers, whatever you want. But it is not suggested to do that.
We need to do that in order to work with memory mapped peripherals, right?
Rust has, they offer a wrapper about everything.
Okay, but still that is using this unsafe operation.
No, yes.
Okay. So there is keyword unsafe.
Yeah, and you can use raw pointers. Yes.
Thanks.
Okay. Any further questions? Yes, please.
You said when doing implicit casts, maybe doing 16 to 8, you get compilation error.
Yes.
How do you allow that?
You have a built-in method called try_into.
Okay.
You specify which type you want to convert to which type, and this method actually returns a result object which has two variants called OK and error, and you must handle all of the variants. And if it's OK, you can proceed. If it's error, you can stop the program.
Some type of static cast with some error checking if the cast is possible.
Yeah.
Also, overflow and underflow of numbers. You said you will get runtime exceptions.
Yeah.
What you do want to have overflow and underflow? How do you allow it?
In the cargo.toml file, you can allow that or disallow this.
For all operations or?
Yeah, follow. Yes.
Yeah, you cannot target individual ones.
You can modify the cargo.toml file if you want to have.
Okay.
But Rust offers methods for safe. If you want adding, you have method for safe adding, which also returns a result object. Okay, if the adding was successful, an error if not. So it's all built in the programming language.
I think the question was, can you, in some part of the source code, make it so that you are
It's not
checking
important.
over, okay,
Yeah, it's
over,
not important.
overflow,
At least you can do
overflow,
it.
and some parts that not.
But you don't need if you have the methods and you can handle it manually.
When you use that option feature,
Yes.
does compiler enforce you to use that match on all the?
Yes, you must do that.
In case you miss something.
It won't get compiled.
Maybe one more. I'm really interested in the topic. So, can you cross-compile Rust?
Yes, very easily. You can add any targets you want using Rust tools.
Okay, but natively, I believe you will be able to, of course, you have the native Rust compiler, you run it, but cross-compiling, you said, to build rules right themselves. And I often hear from Rust developers, it's so great to build it, and it has this built-in features and scripts for building. How much different is it to specify target architecture when cross-compiling and so on? You need additional toolchain, cross-toolchain.
But basically, a simple Rust program you can build using cargo build command, and if you want to build it for another target, you just type cargo build target and whatever you want, and it's get built. And you can automate that in the .cargo folder, you have a file, you can modify it, and you can automatically add the target you want. And when you type cargo build, it will fetch the target and do it for you.
So it's only one compiler for cross and
Yeah,
okay,
yeah.
great, thanks.
It's based on LLVM, so it's something similar as Climb.
Okay.
Okay. Thank you, Harun, for
Thank
your
you.
presentation.